Okay, now we're on to Lesson 7 in Module 4. Writing equations of parallel and perpendicular lines. I think this is the most challenging section in the whole module because it really brings together all of the concepts. So, number 1, write an equation of a line containing the point 2, 4 and parallel to this given line by following the steps below. Write the equation in slope-intercept form if possible, and then we're going to graph both the lines on the same set of axes just to kind of verify our result. Okay, so the first part is what the heck is the slope of the given line? Well, the easiest way to do this is solve for y in terms of x here. And we've been doing this all along. So 3x take away y is equal to 5. I'm going to do this by switching the 5 over and switching this guy over here. So y is equal to 3x take away 5. So the slope is really easy to read off of it. It's just 3. So there he is. He's 3. Okay? Now, using the slope of the line, determine the slope of the line whose equation you're trying to find. Well, we need to write an equation of a line containing the point 2, 4, but parallel to this given line. So if they're parallel, they have to have the same slope. So the slope, again, has to be 3. The slope of the new line has to be 3. Now, we're going to use the given point and the slope to write the equation of the line. So the given point is 2, 4. The slope is equal to 3. So what we're going to do is y minus 4 is equal to 3x minus 2. So actually, this is the equation of the line. But it's really not in a very good form. So what we're going to do is we're going to clean it up a little bit and put it in slope-intercept form. So I'm going to distribute the 3. So it's 3x take away 6, y minus 4. I'm going to add 4 to both sides here. So y is equal to 3x take away 2. So this, what did we find? Well, we found an equation of a line through the point 2, 4 and parallel to this given line. So now let's actually graph both of the lines and show that they're indeed parallel. That'll be on the next slide. So lines are y is equal to 3x take away 5. That's my original. And the other one is y is equal to 3x take away 2. That's my new. So now let's graph them. I love this because they're both in slope-intercept form, so we can graph them really, really easily. So if I want to graph this first one, I'll put a little star next to it since we're graphing it. We're going to start on the y-axis at negative 5. 1, 2, 3, 4, 5. And we're going to go, since the slope is 3 over 1, we're going to go up 3. 1, 2, 3, right 1. Up 3, right 1. I really only had to do 2 points, but let's see if I can connect these dots. Okay, so this is the point, y is equal to 3x take away 5. And now 3x take away 2 is my new line. I'm going to start at negative 2, go up 3, 1, 2, 3, right 1. And there we have it. They look extremely parallel to me. So y is equal to 3x take away 2. I am thrilled because I did a great job. Now let's go on to the goal. Okay, now let's do a perpendicular example. And we're going to follow the same steps, but keeping in mind that we want a line perpendicular. And I think that this one is the most complicated because they're not the same slope. We have to turn the slope in a negative reciprocal and all that stuff. So first thing we need to do is figure out what the heck is the slope of the given line. So I'm just going to rearrange 2x plus 4y is equal to 3. 4y is equal to negative 2x plus 3. And I'm going to divide everything by 4. So y is equal to, and of course what I want to do is I want to write that as a negative 1/2 x plus 3/4. So the slope of this line is negative 1/2. So I'll write the negative 1/2 right here. And we're moving on. So now using this negative 1/2 information, we're going to get the slope of the new line that we're trying to get. So since they're perpendicular, the slopes are negative reciprocals. So I'm going to, from this slope, I'm going to turn it into a reciprocal and negate. Well, it's already negative, so when I negate, it makes it positive. So my slope is equal to 2 regular, which we love. Okay. Now we are going to use this given point and the new slope to help us out. So we're going to do y minus 3, because there is the y coordinate of the given point, is equal to 2 times x minus negative 2. So let's clean it up. 2x plus 4, because these turn into positives, and 2 times 2 is 4. Add 3 to both sides, so 2x plus 7. There it is. So we have two lines, and I'm going to use the original line here, 2x plus 4y equals 3. I'm going to kind of use that in its original form, because I think it might be beneficial. So we'll see how it goes, all right? So here we go. We're going to graph both of these lines on the next slide. Here we go. The new line was y is equal to 2x plus 7. Let's graph that one first because it's a little bit easier. So we're going to start at 7 on the y-axis. Label my little axes here. I'm going to start at 7. 1, 2, 3, 4, 5, 6, 7. And if I go up to right 1, I'll be off the grid. But the other thing I can do is I can go down 2 and left 1. Isn't that clever? It'll still be the same slope. I know. It's shockingly clever. So this is the line y is equal to 2x plus 7. There we go. Now the original line that we had was 2x plus 4y is equal to 3. Okay, so now I just want to graph this line, and I want to grab a couple of points. Well, when we solved for y, we got y is equal to negative 1/2 x plus 3/4. Okay, it wasn't pretty, but we can actually use this one more quickly to graph than using this one. So we're going to start at 3/4 on the y-axis, which is right here, and we're going to go down 1, boop, and right 2, boop, and just graph it right there. It's not going to be that precise, but it's good enough. So now we're going to draw that line, and this is the line 2x plus 4y is equal to 3. And then graphically you can see that these two lines are perpendicular. Now you'll be able to do the MyMathLab work for this lesson, and also the written work that comes right after the lecture. And as always, if you're having issues, please ask your teacher.